3 short talks, 15 minutes each, on examples of indigenous innovation, followed by a panel which will be on indigenous innovation for the future. Our first speaker, Dr. Sharan Murali. Dr. Sharan is a scientist C at ICMR National Institute of Epidemiology, where he applies his expertise as a public health specialist to address critical health challenges. His work involves research on non-communicable diseases such as hypertension and chronic kidney disease, as well as the implementation and evaluation of digital health solutions. Dr. Murali is a key figure in training, serving as a mentor for the India FETP, which is the Field Epidemiology Training Program, and the course coordinator for the Intermediate FETP in Odisha State, the first of its kind. Driven by a vision to enable public good, he is also developing a learning management system for field epidemiology training and aims to establish a center for data computation, analytics, and visual dashboards. He's completed his medical education, including an MD in community medicine from ICMR. Please welcome to the stage, Dr. Sharan Murali.
Colleagues, friends, ladies and gentlemen, a very good afternoon to one and all. So I stand here today representing the collaboration between the Indian Council of Medical Research, the National Institute of Epidemiology, and the Center for Data for Public Good to discuss a problem that we have been trying to solve. So since we just finished food, any thoughts on what are your favorite food? Anybody? Paneer tikka. How sure are you? Who knows it best? Your mom? Yourself? Girlfriend? Exactly. That's the answer. Right? So Swiggy remembers what you like, when you like, how you like it, right? So one fine day, my boss is sending me an email telling, the contract finally came through. Let's start the work without much delay. And then Google is suggesting me replies. No worries, thank you. Great news, thanks for the update, that's great. How does it know how I reply? Right? So welcome to this new world that we call as the world around artificial intelligence. Now coming from a health background where we work with the governments in the country to solve public health problems, including investigating disease outbreaks, setting up disease surveillance systems, and conducting research in the field for the priority areas picked up by the state governments. Can we use these skills to predict outbreaks, to find out if in the next rainy season, which area is going to have an outbreak of malaria or let's say dengue, so that you can prevent that particular population from getting the disease? So to create this system, we understand that we need a large quantity of good quality data to understand the trends and the patterns. Do we have it? The answer is yes, we have the data. In India, we have the communicable disease surveillance data, which is sitting in the integrated disease surveillance project, which is called as the IDSP, which is currently in a portal known as IHIP. We have all the laboratory data or laboratory tests conducted under around 160 plus surveillance networks, which is known as a viral research and diagnostic laboratory network, which is sitting in various medical colleges across the country. And periodically, while you're reading the newspapers, you'll be hearing about sero surveys being conducted to understand the prevalence of a particular disease, the antibody prevalence, etc. in the populations. We also have the disease outbreak data, which is sitting either in the government portal or within the particular investigator's laptop. So on and so forth, but all these data systems are working in silos or are sitting in silos. Now, if I put an effort to bring all of them together to start talking to each other, do you think we have the capabilities for it? And that's when we realized that if I start combining this, the first problem is lack of standardization. For example, I might store the information about fever as fever, somebody else might store it as pyrexia, a doctor might write it as temperature, right? Like 104 Fahrenheit, etc. We then have the problem of different systems sitting in different servers. For some, the backdoor is closed. It's not interoperable. Now, how do I bring them all together? And finally, I also have the problem of like IHIP have been running for the last 5 years for the entire country. Every ASHA or the ANM or the community health worker, we call them, uploads their data, such huge amount of data. Do I have the capability of combining all of them together to make them into epidemic intelligence, what we call? So this major problem led us to the understanding that there is a definite need to standardize data sets at the first place, to make them machine readable, and thereby combining them for building epidemic intelligence. We decided to take the lead in bringing these data sets together in one place through the epidemiological skills that the ICMR National Institute of Epidemiology is known for, and the data skills of CDPG, to make them into meaningful information which can be put forth for action in the field. So with these experiences, we built the portal which is named as the Advanced Data Analytics for Public Health Action and Research Venture, or we call it as ADHR. So ADHR primarily aims at two different things. One is to set up a data exchange platform with the capabilities for automated analytics and epidemic intelligence by synchronizing and standardizing data sets. It also aims to foster research where independent researchers and organizations can come together, access data sets, and work on it together in the same platform. So what all can ADHR do? So the data standardization application basically uses SNOMED-CT and FHIR, which are the basic ontologies that we are building, which will make the data standardized and stored. We have an automated report generation and data playground capabilities which generates routine reports that are required for the field. Say for example, you're doing an outbreak, you need everyday reports to be sent up into your pipeline of reports. The system generates it automatically. We also have a data anonymizer which removes the identifiers and anonymizes data sets. We have created a pipeline for making sure there is a consent and agreement processes so that your data can go to public. And finally, we also have a dataset combiner which will start looking at datasets together. For example, there are, let's say, X or 10 outbreaks that have happened in the country. In how many of these outbreaks was cholera reported? How many of them had reported bad quality water? So such analysis are possible with this dataset combiner. So let's briefly touch upon the SNOMED-CT and FHIR. SNOMED-CT, which stands for Systematized Nomenclature of Medical Clinical Terms, and FHIR, which is Fast Healthcare Interoperability Resource. Let's say, for example, in your dataset we have fever, right? We were using the example for fever. There is a high-grade temperature, that is pyrexia, fever, etc. can all mean the same, but it's difficult for the system to understand it. So, can you please play it? So, SNOMED-CT has over 35,000 unique clinical terms. Say, for example, if I search for fever, okay, it tries to show you various types of fever, and then within fever as the parent, you will be able to understand body temperature above the reference range, and then there is a SNOMED-CT code. There is a number which is associated with fever. So, we will want to make our data machine readable by converting them into these ontologies, right? So, for the people from tech background, this might sound very easy for you, but coming from a medical background, this is a very difficult thing for me because I'm used to writing fever when a patient comes to me rather than writing that number. So this is a challenge that we wanted to solve at first. So SNOMED-CT has got different ranges or different domains for findings, disorders, environment, event, observable entity, or anything that a doctor would prescribe or write in a prescription or medical record can be converted into a SNOMED-CT code and can be stored and can be used. Similarly, we have FHIR also, which is mainly used in electronic health records at the hospital setups. So we combine both these resources together in our backend to understand and analyze datasets. So while working with the various government and with the India field epidemiology scholars, we understood that outbreak datasets are very key to understanding the epidemiology of the disease, and immediate action can be taken in the field when an outbreak is going on. But rarely these datasets get fully analyzed, right? So we wanted to give an extra hand to these particular scholars to use them, and that is why we built the first domain on outbreaks. So currently the system can analyze outbreak data, whatever data you are uploading to the platform, it can generate outbreak reports and give it to you as downloadable format result. We are currently working on trying to look at surveillance data sets, and the similar concept will be applied to research as well. So what does the outbreak module specifically do? Right? If a user upload the dataset onto the platform, our AI application will try to standardize the datasets based on SNOMED and FHIR. It will generate the routine reports, after which we can have a data playground, which is like a digital data query page where you ask questions to your data and then get the results accordingly. Because I am talking to users who are very primary in their use. Excel itself is a difficult task for them. So how easy can I make data analytics for them is the question here. And finally, a data discovery page. If you have the necessary permissions from your government setup, then you put your data in public so that another engineer or a data science person can work on that data set to generate even more better analytics out of it. So let's try to quickly see a small demo of what happens if you upload a data set. So here we are going to upload a data set. Okay, so the data is getting uploaded right now, and you get to select the sheet in which the data is sitting, and then our system analyzes it in the backend and compares it with the set ontologies to standardize your data. So once that task is completed, it tries to ask you certain specific questions on, do you have data of only individuals with disease or individuals without disease also? We try to call it like, say, is it like a cohort data, or is it only the sick people data, right? And then if it's an outbreak, it tries to take you the date of the outbreak. And then some things that are very easy for us are very difficult for them. We try to create an easy portal for them to make categories out of continuous data for, let's say, age groups, right? And then now this is the preview page where you see how AI has categorized your variables, compared them into the symptom, exposure, socio-demographic, etc. It started understanding what is your data set values, which are ones and twos if you have done it. How do you want your results to be? They are the possible values that you can edit here also if you want to name your variables as differently, like male, female, yes, no, etc. And then here you choose what type of data it is. Is it like a case control or a cohort? And then the date for epidemic curve, which we call the distribution of cases across time. Right? And that brings us to the analysis page. So the overall maximum we would have taken, let's say, 5 minutes to load the data and finish the analysis. So we have analytical table including, odds ratios and relative risk being generated. And we also have the epi curve, which can be changed by hourly, by week, by month, by year, and even the color. So why the color? So when we were working in COVID, one scholar came and told us, I don't want this graph in blue. Why? Because my commissioner likes it in orange. I want it in orange, right? So we were trying to understand what the user wants. We did a lot of user research in this on what might work in the field and tried to come up with this platform. So the results are downloadable as publication-ready tables, which can be put into any report. You can download as image also and then paste it and send it across. We are right now trying to work with IDSP to standardize the reporting formats in the portal. So this is our no-code ecosystem where we don't have to, literally know what we are, you don't have to type in any codes, but you can drag and drop. Okay, I want to load the data set. I can load it. Okay, I want a correlation plot or I want a condition plot. You just connect both the dots and then you deploy it. You get your graph. Taking things one more step forward, we also wanted to integrate, sir, can you play? We also wanted to integrate a chatbot with Other, which can talk to the data set and get the desired analysis and outputs. Maybe if you have a paid subscription of ChatGPT or any other GPTs, you might be able to do it, but this is health data, privacy is important. So we tried to build our custom GPT where you can ask questions in natural language and it will return back the results also in natural language. So this is very difficult in the time being in the health system where you ask, like the commissioner or the NHM director asks you a question and it takes time for the health system staff to go back to their data sets and come back with the results. So this is an easier solution for them to talk to their data set and get the results faster. So other also has policies for storing the data and also sharing it with other users in a catalog page where you have user defined access restrictions. You don't want the data to be shared, you want it to be deleted from the system, you can do it. That is our private sharing policy. You have a limited access, you don't show the data outside but only the results outside, so interested people can get back to you and talk to you and get the data. That is possible. If it's a public funded research and you want to put your data outside, then public access can also be given. That is like data out, open data can be given. We also want to build in the legal policies for doing this accessible data sharing policies into the system itself, so that anybody, let's say somebody is working on dengue or anthrax and they want to work with multiple data that are available on the health system portals, they can come over here, fetch the data, talk to the investigator and plan further studies and analysis. So we understand the complexity of what we are building, and other will be compliant with all the existing rules and the guidelines for personal data protection, security, and the ABDM under the GOI. So we envisage Adhar to be a one-stop platform for the public health professionals to do data curation, analysis, and even interpret the same for infectious diseases. So thank you all for patient listening, and we as other team are actually open for ideas to work with other data partners, technology partners, and legal partners to take whatever we were building. Like right now, this is a funded project, but we want to take it further again. And we wish Adhar becomes a pathway for better utilization of health data in the country, the data sets that are sitting in the public sector domain, like including outbreaks, surveillance, and various researches. Thank you, CDPG team, for this opportunity. Open for questions.